In this video, we will learn how to find out the profit maximizing level of output when we have the cubic cost function. The question is, a firm has following cost and demand functions, that is C is equal to 1 upon 3 Q cube minus 7Q square plus 111 Q plus 50. This is the total cost function. And demand function is Q is equal to 100 minus P. We need to find out the profit maximizing level of output, and we need to find out the first order and second order conditions for profit maximization here. Okay, so let us solve it step by step. Now, in case of profit maximization, we know that first thing is we need to find out the total profit. So total profit, let us denote it by pi. It is equal to total revenue minus the total cost. Okay, now we know that total revenue is equal to price into output, okay, minus the total cost. So first we need to solve this demand function for P. Okay, so solving for P, what will happen? So P will be equal to 100 minus Q. Okay, so we got the value of P here. That implies our profit will be equal to, so P is here 100 minus Q, that is, to this we multiply by Q. Then we have the total cost minus times 1 upon 3 Q cube minus 7Q square plus 111 Q plus 50. This is our profit function. Or if we solve it further, it will become, so profit will be equal to 100 Q minus Q square minus Q cube divided by 3, minus into minus is plus 7Q square, then minus into plus is minus 111Q minus 50. This is our profit function. If we solve it further, so what will we get? And let us find it out here. Let's take the derivatives now. So first order condition for profit maximization requires our marginal profit should be equal to 0. That is, the change in the profit due to the change in the output should be equal to 0, which implies we need to differentiate this function with respect to Q. Derivative of Q is 1, so we are left with 100 minus derivative of Q square is 2Q minus derivative of Q cube is 3 times Q square. So we have Q cube upon 3, its derivative will be 3. Exponent becomes coefficient, then exponent is subtracted by 1 by power function rule divided by 3. So 3 gets cancelled. We are left with Q square only, plus derivative of Q square is 2Q. 2 into 7 is 14. Q minus derivative of Q is 1, so we are left with 111, and derivative of a constant is 0. Okay, and we set it equal to 0. So solving further, okay, I have the space to solve it. So d pi upon dq will be equal to, so d pi upon dq is this very thing, and we set it equal to 0 here. Okay, so solving further, let us find out if we can solve it. So transpose these terms to RHS. So we will get Q square plus 2Q, okay, plus 111, or let us solve it here. So let's write first we have minus Q square, then we have minus 2Q plus 14Q, so it becomes plus 12Q. Then we have 100 minus 111, it is minus 11, and we set it equal to 0. Multiply both sides by 1, negative 1, so we will get Q square minus 12Q plus 11 is equal to 0. Okay, so what we did here, we multiplied both sides by negative 1, here also by negative 1, okay, to get this very quadratic equation. So let me see if I have the space. Yes, I have. Now, since this is a quadratic equation, we need to solve it in such a way that the sum of the two numbers should be equal to the coefficient of the middle term, which is minus 12, and product of the same two numbers should be equal to the constant term, which is 11. So by visualizing this, so we can see minus 11 minus 1 satisfies this condition, and negative 11 and negative 1 satisfies this condition. So negative 11 times negative 1 is positive 11. So can we derive it q square? In place of minus 12q, we write minus 11q minus q, and in place of this plus 11, can we write minus 11 into minus 1, and we set it equal to 0. So factor out q in the first two terms, so q is equal to q minus 11 here, and let us take minus 1 common from the last two terms, so we are left with q minus 11 is equal to 0, which implies, let's take now q minus 11 common, so we are left with q minus 1, and it is equal to 0, which implies either q minus 11 is equal to 0 or q is equal to, rather q minus 1 is equal to 0. This implies q is equal to 11, and this implies q is equal to 1. Okay, so we got two values for profit maximization here, and we need to find out which of these satisfies the profit maximization. So for that, so when we solved it, so let me write it here. We got, I have the space, so we got q is equal to 11 and q is equal to 1. Okay, so now let me rub this out. If I draw a simple graph, since we have the cubic function, it will look like this. We will have a this kind of function. Okay, so this is our profit function. So we see that to find out the maximum profit, what we do, we take the first order condition. First order condition is used to find out the point where slope is equal to 0. Now slope is equal to 0 means the marginal profit should be equal to 0, and we find out slope is equal at 2 points. Q is equal to 11 and q is equal to 1. Now we need to find out the second order condition. Okay, for second order condition, for maximum or minimum, what we need to do, we need to take the second derivative of profit function. Okay, so second derivative of profit function with respect to output, and we need to evaluate it at critical point. So let us first find out the second derivative of the profit function. So this was first, this is actually our first derivative of profit function. Let's take the derivative again. So derivative of q square is 2q minus derivative of no, this is not our profit function, rather d pi upon dq was this very function. Okay, so let us take its derivative again with respect to q. So derivative of a constant is 0, derivative of q is 1, so we are left with minus 2. Derivative of q square is 2q, so 2q, and then derivative of q is 1, so we are left with 14. So this is second derivative. Okay, now we need to evaluate it at pointers, that is at q is equal to 11 and q is equal to 1. Let us put it when q is equal to 1 in this equation. That means d square pi upon dq square when q is equal to 1. Let us plug it here. So we have minus 2 minus then we have 2 times the value of plus 14, so it is minus 2 plus 14, it comes out to be minus 4 plus 14, so which is equal to 10, which is greater than 0. Okay, now For second order condition, the second derivative for profit maximization should be negative. Okay, for second order condition for profit maximization, that means d square pi upon dq square. When we evaluate it at the critical pointers, it should be less than 0, but here we are getting positive one. Okay, so that means this will not maximize our profit. Now let us put d square pi upon dq square and evaluate it at q is equal to 11. Okay, so we have minus 2 times 11 plus 14. Let us find out here. So here we have minus 2 minus 22 plus 14, so it is minus 24 plus 14, which comes out to be negative 10, which is less than 0. Since second derivative came out to be negative, we can say that q is equal to 11 satisfies the profit maximizing condition. Okay, so at this point our q is equal to 1, and at this point q is equal to 11. Now, as I have told you, profit to find out the profit maximizing level of output, first we need to find out the slope of the profit function. So slope of the profit function should be equal to 0. It came out at this point and at this point. Now among the two, we need to find out which of these two satisfies the maximizing condition. That is, when slope is equal to 0, then we take second derivative, and if second derivative is positive, then we get a minimum point, and if second derivative is negative, we get the maximum point. So profit will be maximized when q is equal to 11. I hope I make myself clear in this video and you find out this video helpful. Thank you.